Okay, so my group did our poster on fossils, obviously, and fossils provide record of the past, and they show like how different organisms have evolved over the years, billions of years. Fossil records show that life is old and has diversity. Um, and so right here you can see how the horse feet have evolved over years because the ground used to be really marshy and kind of soft, and then over the years it got harder and harder, which forced the horse to evolve to have more of a hoof, a harder hoof. And so fossils are found in rock layers, and obviously the oldest fossils are in the bottom because the rock has formed over them over the years. And only a few percent of our past animals have been fossilized. It's kind of by luck that happened. We're very lucky. And fossils can be used to reconstruct an organism and show the environment that they once lived in, like dinosaurs, for instance, like Jurassic Park. And fossils allow us to know what a world would have been like 3.5 billion years ago and what the animals would have been like and how we've changed.
Okay. A fern and the Venus flytrap, they have homologous structures because they have a common ancestor. You can see in these pictures, they have like the same like bones and parts. They've kind of adapted to their environment over time. You can kind of compare the structures and see how the different species have evolved. But on the other hand, then there's like the bat and the butterfly who look really similar, but they're analogous structures because they don't have a common ancestor. They're different. They both have wings, but they both do a similar job, but structures.
So the last one is like the horses. So it used to be like really wetlands.
And like the
so
vestigial structure, it's the random things that you don't have any use for. Like the kiwi birds, they have these wings, but they can't fly. And we have appendixes, and they might have used them a long time ago, but we have no use for them now. And like the whales, they have random bones.
You get any of that? Yes. Okay.
Charles.
It's because what I said here, you can kind of compare the different structures to each other and see how the different species have evolved over time and adapted to their environment.
As it got dry. And environment and diversity.
The vestigial structures, and their species, they are
constructed organisms and
structures in a species that are similar to an ancestor, but are different due to the different selective pressures in the ancestor.
That's it.
So cell-walls, the trail, and chloroplasts are the ones who can write. And the second one was what might be an explanation for these instances. You guys know at all? Any idea? No? Well, we got that they were once one species, but then they mutated over time.
The other one is that natural selection provided a mechanism for evolutionary change.
And then for you just want to look at the third question, which is the amino acid sequence of certain proteins can be used to show how closely related different species are.
So involved also made observations of nature, and
And the next one is how do the number of amino acids in each protein compare between humans and different species? And then we said that they're more related and they have more in common. Oh no, the more related they are, the more they have in common. That's what we got from that one.
Jeffrey, why do you just shut up and you talk?